Hello, everyone. Today we're going to hear how to go from a single Kubernetes cluster to a whole range of them. So please let's give it up from our friends from Albert Heijn, Joost Hofman and Reinier. Yeah.
Oh, hello. To clear up the confusion, that's Joost. I'm Reinier. Well, the dust is settling, I think. Smoke still rising. Oh. Wait until you see after the presentation. Yes, we're from Albert Heijn, and I'd like to start with a question. Who has seen the talk by Bart Engelaar? He had 2 talks, I think. But the second one is like breaking down the room because he was so enthusiastic about how it is to be a software engineer. And that's, well, kind of speaks to me how great it is to work in IT. I mean, there's something new every day, basically, and every day you can discover the next big thing. And it also reminded me a bit of when I started at Albert Heijn, close to 3 years ago, and I met that guy, and I ended up in a team with him, and we were building something new for Albert Heijn at the time. It's called an open API platform, and that guy, man, was he enthusiastic. He was saying, we have a monolithic application, and it completely sucks. We're going to take it down. We're going to build microservices, do Node.js front ends, and build an open API gateway, containers, and everything. Every cool thing that everybody wanted to have, but no one was really doing, and we're just getting started with it. So I thought 2 things. First, wow, who is this guy? I mean, he's very passionate, he has a vision about what we want to do, and also, yes, this will be big, probably. So we knew what we wanted, but of course we have to have something to lend our vision on. And if you want to do containers, your old infrastructure won't do. So we did what any sane team at the time would do. We wanted to use a container platform. And we didn't choose Docker Swarm, although I liked it at the time, but we chose to go with Kubernetes, who was, I think at the time, still version 1.3 or so. It's 11 versions back already. And yeah, we wanted to have that. But of course, we were not running on a cloud. And we had a hosting partner who couldn't just give us a Kubernetes cluster because we wanted it, so we had to basically roll our own. But they gave us the next best thing, which was a single pet. This was our pet for the start of the project. And, well, do you still remember its name? AH.nl 1544?
I called it Willie.
Yeah, you called him Willie, yes.
Yeah.
Well, we called it the Docker machine because it was at the time, if this thing is working, maybe it's not. I don't know. Technology letting me down.
I think your laptop is dying.
Yes, it's already dying. I don't know what's wrong. Well, it was, believe it or not, a single server running Docker. So that was, I think, at the time was also the only machine in our entire data center that was capable of doing that. And we were thrilled to have it. We were over the moon, so we could now start our containers. But of course, the advantage of having a guy like Joost in the team is that it never is enough. And we had to move forward so soon. We had 3 pets. And now we were getting somewhere. Because these pets were basically the starting point of our first cluster. And we were using a tool which is called KubeSpray, which can spray some Kubernetes magic on existing infrastructure. And before we even knew it, with a little bit of cowboy mentality, we had our first live cluster and our first live API. And now I'd like to give the floor to Joost, because he's smiling and he's unusually silent. That almost never happens. So
I love this story.
Yeah, you can do some talking.
Thank you. So from that one cluster in where we run production with, basically
on test,
we
yeah.
didn't tell anyone. We had to move forward, so we created acceptance clusters, production tools. There were still kind of pests because we knew exactly which server name was which node, so it felt like we knew them. But then at one point, yeah, you have to upgrade again, etc., and you get more and more and more nodes in your cluster. So all of a sudden, those things became kind of kettle.
Out of hand, yeah.
Yeah. Even our pet, somewhere there, Willie, became like, I think, the master one from the tools cluster, so there's still a bit of a pet then. But it became our kettle in 2018. But when growing those clusters, we had a lot of challenges. One is the operations part, operating clusters on-premise with non-elastic infrastructure is horrible. Well, developers were going YOLO and put all new containers up and etc. And then our capacity was like, shit, we only have 10% left. We have to order new servers, takes 3 months. Oh, damn, too late. So that was horrible. Upgrades, it went good the first time. The second time we run the Ansible script, we had a whole other outcome. So how is this possible? We only do upgrades with Ansible. But since we don't host those machines ourselves, our hosting party does stuff too on those machines. So at one point, we didn't even dare to upgrade anymore because we have no idea what would happen. Then you got role-based access control. So we want to do DevOps, we want to give developers all kind of permissions to do stuff in production. Then you have to enable Airbag in a way that you can also maintain it. And that is also, if you have a lot of clusters, is a really hard thing to do. And of course, tooling for DevOps. So we had one dashboard for admins, one for developers, but we didn't have any dashboards, especially for that user that was logged in. And also for things like kube control. We created like a jump server for people to log into, but it was quite hard to do that. That's 2018. So now we're in 2019, and finally we can go to the cloud. It's not Google, but Azure, but at least it's cloud. And we want to spin up a lot of Kubernetes clusters there. I think we saw there 4 before, now we're thinking already of 20 clusters. So make smaller clusters, mitigate the problem, etc. But how are we going to manage all those clusters in the cloud? And especially, maybe we want to move later on to Google or to Amazon or whatever. How can we still be a hybrid cloud and be elastic? So we found a tool called Venture, an open source tool. And that would solve our problem. And why? It creates for us CAS. It's the highest search term we have in our platform, but also now our other platform.
Yeah, even our customers love CAS.
Yeah. We always test stuff on CAS, and it's so fast because it's always being cached. So Kubernetes-as-a-Service it provides. So it's open source, and we like that. We can contribute it, we can see how the source code works, etc. And we can scale up and down as much as we want without having too much cost. Airbag is arranged on a central place, so we connect our LDAP to it, and from our LDAP, people have groups, and with those groups we can give role-based access control over all the servers we have, over all the Kubernetes servers. Logging, monitoring, alerting out of the box, so we don't have to think about it anymore. Really nice. A lot of tooling is around there, so if you know Helm is a packaging tool for Kubernetes. So you have like a whole shop thing inside Reinier, so it looks awesome. For us, multi-cloud on-premise, so what I said before, maybe we want to move to other clouds, so we still have to manage our on-premise clusters, so Reinier goes over all those environments. And I think really important for us is scaling. Auto-scaling, up and down, don't have to think about Christmas anymore coming in April, right? We're thinking about Christmas around that time. So we can stop doing that. So it gives a lot of benefits. So how do we roll those clusters? It needs to run somewhere, so we want to run it on Azure and we want to run it high available. So then you get a chicken egg problem, so we have nothing there. So how do we get Reinier on a Kubernetes cluster to make it high available? Because Reinier makes the Kubernetes clusters. So we use Terraform for that. So we spin up an AKS cluster, an Azure Kubernetes Services cluster, and there we spin up Reinier. So that's solved, and from that part, Reinier spins up all the different clusters we have in the cloud. So how does it look like? So we have a dev, test, acceptance, and production Reinier, and with Ansible, basically we talk to the Reinier API and then make Reinier do stuff. So these are basically more for us, as an SRE team, to test our dev, test, and acceptance environments, because also we want to do this as software developers. We want to go to the OTOP street. And then production. But for developers, we don't want them to have to be logged into dev rancher if they want development stuff, test, etc. So it's a burden. So we created a DTA rancher for that. So developers can log into one rancher for DTA, and from there they can manage all the clusters from development, test, and acceptance, like this. And production is still separate, and therefore they can log into there. So how do we roll out a new cluster with developers? So one of the things that we really want to do is work with GetOps. So what a developer does, it makes a pull request in our repository with a file that looks a bit like this. So we have some metadata that tell us, okay, this is the size of a cluster we want. This is the access to the cluster, the size, the environment, and basically we get a pull request from that within the SRE team, we approve it, and automatically the cluster is spinned up and ready to use for the team. And it works quite nicely, and we can also, if the rancher crashes, we can just rebuild everything from scratch in one time. So I think most important is, the demo.
Yes.
And you're going to do that, right?
I'm going to show you some things. Basically, I will show you the rancher application as we created it, and that's what most developers will see as well. So if you have any questions, you can always interrupt me, because I'm just going to click through it a bit. But if there's stuff you really want to see, don't hesitate. Let's see, where are we now?
That works.
So this is the rancher dashboard in all its awesomeness. This is our production rancher, so we only have 2 clusters at the moment for now, because we're not migrating our own production workloads yet. But so we have a cluster for CI/CD tooling and for other kinds of tooling, and you can use this dashboard to investigate those clusters to see what's going on. So you have some basic monitoring. So there's 3 nodes here, and there's pretty much nothing going on yet, because only one team is just starting to migrate some code to it. But you can already, see some nice red bars. And this is actually because we are using Azure Kubernetes-as-a-Service. We don't have our own control plane, so we don't have our own controller manager. So there's a bit of a bug in Rancher still, but they will solve it sometime, or maybe we will solve it, I don't know. And you can have some other metrics here as well from the dashboard to see what the utilization of the cluster is, or well, it has logging built in via FluentD out of the box, so you can also inspect that here. And for the command line lovers, there's also just your online shell, which you can use to get some information about the cluster if you really need it. So you can do kubectl, or basically everything you can do with a normal Kubernetes cluster as well. Let's see. This was CI/CD. Is something happening here already? Yeah, something working on the key vault, and they're setting up Jenkins. Okay, well, at least you can inspect everything from here if you have access to it, and I do. But there's also, well, yeah, how awesome! But because Rancher also takes care of the RBAC, you put in groups in your LDAP, and if you don't have access to a cluster, you cannot see it, or you can only do limited things. You cannot operate the cluster, or you cannot view certain namespaces. You can also download a kubeconfig file for the people who know it. This one allows you to use kubectl, but then from your local machine. And also with the same LDAP groups. So you can do, it has a lot of tooling out of the box and a lot of standardized tooling as well. So you see here all the Grafana logos. You can open a Grafana dashboard as well. So it uses Prometheus and Grafana underneath. And basically this shows the same thing, only in a different dashboard with a black color scheme, because that's what we like. And you can inspect individual nodes. So this is a cluster of 3 nodes. It can scale up and down because the cloud supports that as well. Either automatically when you set up auto scaling, or you can add nodes here. And if you have to do some maintenance, you can do select a node to do cordoning, which means you remove all workloads from it, and you can drain the node. Oh, no, cordon is you don't schedule in new workloads, and then you drain the node where you take out all the workloads, and then you can reboot the virtual machine. And you don't need any command line for that. You can do that just via Reinier. So there's more things. Storage, projects, namespaces. It shows which namespaces there are on which project. So you can use this to, well, put certain Kubernetes namespaces for certain groups, so that not everybody gets access to the same thing. Members, here you see, well, the LDAP groups that are tied to that. So if you are in team tools, which I probably am, I'm owner of the cluster, but if I'm in one of these groups, then I'm only a member, so I cannot do administration. And it doesn't just work with Reinier, but it also works with Kubernetes itself. So you can also do the admin operations in Kubernetes if you're in the right groups, and if you're not, you're out of luck. It's a lot easier than doing this kind of RBAC things by hand, because now we have something like an all or nothing RBAC. So you're admin or you're just rest of the people. And also it has alerting and monitoring built in, and logging. What can I show? The alerts are nice. So you can define all kinds of alerts. Basically, this is nothing specific to Reinier, but it's just Prometheus. You configure via Reinier. You can define all kinds of alerts. For example, if CPU load is too high on a certain nodes, then alerts go off. I don't think you see anyone right now. No, then it would turn red. And for all the alerts, you can also specify how your notification works. So you can send notifications to different kinds of cloud chat teams, chat groups. And something more is you can also add your own catalogs, which are basically Helm repositories to install additional applications. And you can even install applications on a cluster using Reinier. So basically you can use Reinier for almost anything. For example, let's see what I want to install. WordPress, why not? WordPress on our CI/CD cluster. Makes zero sense, but who cares? So, and then it's without me having to know how Helm works, I can just install some, after scrolling down, so my WordPress target project, I want to put it in the default project so that cluster members have access to it, and the rest I'm just going to ignore and just going to launch. Of course, I don't have permission because I'm cluster owner, but not project member. Well, it's RBAC at work. So these are kind of the small things we like to show. But the nice thing is, because we are now the SRE team and we really like GetOps and infrastructure as code, these things have been built completely without looking at the dashboard. We use automated pipelines for everything. And also if you want to install additional applications, you can do that via automation as well. So it doesn't matter who's behind the buttons, because if I know Joost, if he is going to spin up a WordPress, it will look totally different from the one I will spin up. So, so there's that. And I think this basically sums it up, what we are doing with Reinier at the moment. So we're still in the process of migrating our workloads to Azure, and we're going to use Reinier to help us out with that. So do we have anything else? Demo time? Hey, thank you.
Our kettle.
Yes, this is our kettle. This is our future. So does anyone have any questions or anything else you'd like to see? Yes?
Two there.
So what's the number of services that you have, and what's the number of planned services to go to cloud in this year?
Well, everything will go to cloud. This year, I'm not sure, but do you know the numbers?
Services or servers?
Services.
So for the APIs, the components, because more than services we have, so everything is built also with React components. I think right now we have around 70% within Kubernetes, and it's all built the same way with Helm charts. So it's really easy to migrate it to the cloud this way.
In theory.
In theory, yeah.
So how many containers do we have now running on production on-prem?
1600, something like that.
1600?
Yeah, it's going crazy. Yeah.
Well, they will all be on Azure.
Yeah.
Yes.
Thanks. Hi. So, how does inter-cluster communication work? Is there like service discovery across clusters, or do you have to go through egress gateways on both sides?
At the moment, we haven't set up anything between clusters. I'm not sure we were planning to do that, but we use the service discovery that's built into Kubernetes.
Okay. And do you know if Reinier supports that?
I think they're building it now. I think they have a project that builds the communication between clusters. For us, right now, we don't need it. So if they have to talk to each other, it's got with Ingress. And then we have an API gateway if the API is in front of it, secured. But they are building it. But still, you don't have to use it. So if you want to use something different to connect those clusters together, I think Istio also provides that out of the box. That's possible too.
Cool, thanks.
Yeah.
Any questions anymore?
No?
Then this is it. Thank you very much.
Thank you.